What, how, and why blockchain for libraries. Okay, so this is a lot of what I've been spending my time on at the Berkman Center at Harvard. And I've been having ongoing arguments online with a gentleman over in the corner there about whether or not this is actually a useful tool. So there are people who disagree with me, even in this room. So if you, if what I described seems like magic and fairy dust, it is possible it is magic and fairy dust. I don't think so. Others do. So,
there's nothing wrong with fairy dust.
there is nothing wrong with fairy dust. If you want to tweet questions at me as I talk, at Griffey is my Twitter handle. So let's talk about blockchain. How many people in here have, before you read the description of the talk, had ever heard the phrase blockchain? Okay, all right, quite a few of you. Okay, yeah, for me, no, that doesn't count, right? How many people in here have heard of Bitcoin? Almost everybody. Okay, so even the people that don't know blockchain know Bitcoin. That's usually the way it works. How many people in here have some Bitcoin?
Had it.
Had it? Okay, that counts too. That counts. Okay. All right, so a couple. All right. So, in very generically, we're going to talk about a little bit about how blockchain works, why it matters, why it's important. But very generically, blockchain is the technology that makes Bitcoin work, right? So blockchain can make other things work. As a matter of principle, right now, it has only really fully been instantiated in the Bitcoin currency world. It is just within the last year or so kind of been, people have realized that you can divorce the underlying technology from that particular model and apply it to other ways of doing things, other kind of products and projects. So that's what I'm going to talk about, is how and what does it look like? What is the blockchain? Why do we care? What does it mean? And then how does it apply to some potential projects that are either libraries or library adjacent? So at its core, if you boil it down to the simplest of simple, blockchain is just a ledger. It is a list of transactions, right? There are lots of ways to instantiate that. Libraries are familiar with lists of transactions. We know how lists of transactions work. We know how to use them. We know how to keep them private. There's a lot of things that we have done that effectively boil down to lists of transactions, right? But the other way to think about a ledger, which is structured information in some sort of order, the other way to think about that is a database. They are effectively the same thing. They're both structured data you can reach in and find and then pull out. We are probably more comfortable these days calling things databases than we are calling them ledgers. We think of ledgers as something accountants use. We use databases, but when it comes down to the actual information contained inside, they're fairly interchangeable. So when you think of, when I say that blockchain is a ledger, it's a list of transactions, it is a special list of transactions that acts in really weird ways and does almost pseudo-magical things, but it is basically just a list of transactions. It is also basically just a database. Those are sort of the same thing. So, what sort of magical properties, right? So I said that the blockchain has kind of magical things going on with it. What kind of magical things does it have? Well, one of the things that makes blockchain a particularly interesting sort of way of storing data is that at every step, all along the way, every interaction with it, the identity of the person doing it is verifiable. Now, that doesn't mean they know it's Jason Griffey, but that every Every time I do something to the database, it's noted, it's me, it's provable that it's me, it's provable the time I did it, like all of that sort of information is encoded in the way the data is stored. And the other thing is you can have as many people writing as you want. You can have billions of people all writing to the database simultaneously, which is crazy town if you've ever done database management, right? Having huge numbers of hands in your database all at once is the kind of nightmare scenario for most people that have dealt with databases. But it's true. With a blockchain in general, you can have hundreds of thousands of kind of entries going on, more or less simultaneously. You can even have authors that are bad actors in the situation, right? So you can have authors that you don't trust, that you don't know, that are anonymous, and you can still let them kind of write to your database. The thing that I find most interesting about it is that among the other magical things that blockchain does is it entirely decentralizes information storage. So the way Bitcoin works, and not all blockchains work like this, and the blockchains I'm going to describe later may or may not, but I'm going to use Bitcoin as my instantiation of blockchain at this point. In the way that blockchain works, everyone that does any kind of work with the blockchain has an entire copy of everything that has ever gone on all the way back to the initial coin that was mined. So the entirety of all of the information is instantiated at every point of everyone that works on it. Okay? Now this gets big. I think the current Bitcoin blockchain is like 36 gigs or something. It's pretty big. Do you know, Eric?
56.
56. Okay, that's bigger than I thought at this point. I just downloaded the installer and it told me 30 something, but I figured that was out of date. So 56 gigs. So it can get very big. But everyone having a copy means that there is no way to destroy it, right? Like you can't, there's no there. It's completely decentralized and available everywhere to everyone. Robust resistance to manipulation. So again, using Bitcoin as an example, but blockchain in general, there are a series of rules that run how the ledger entries are entered and then how they are connected to each other. And the way that happens makes previous entries almost impossible to change. So once there is an entry in your data store, it's there. And bad actors can't go back and change things, right? Pretty good. And then validation for ledger entry. So every entry, we talked about verified identities, every identity being verified. Not only that, but every ledger entry, every individual entry can be verified by looking at the next block and be kind of revisited by looking at the next block in the link in the line. And because of the way, again, the blockchain works, the magic fairy dust, anyone can look at everything in the chain anytime they want. So I can query the data anytime I want to for anything in it. Completely, verifiable. I can verify any change in the ledger. I can go back and trace individual people in the ledger. Even if they're anonymous, they're still, they have a code that I can follow. And I can independently verify that the given state of a ledger at any point. So the database, in this case, if we're talking about a database, can be at any point in its history can be verified to be correct, effectively. Just kind of magic. So this is a list. I'm going to talk about 4 of these as we go forward. First, I'm going to talk a little bit about the magic behind it and why it's called a chain, why we call it the blockchain, what is going on, kind of underneath the technology that helps it get where, with all, helps all the magic we created. So let's imagine that we have a ledger. And this is the same ledger that I showed you before, right? A little 4-line ledger right here. And each of the individual entries gets kind of written to the chain. So we give that a name. When it's written to the chain, we give it a name, block 43. The next block is going to be block 44. That's a big surprise. And one of the things that block 44 contains is a hash, kind of mathematical description of block 43. And block 43 contains block 42, and block 42 contains block 41, and block, blah, 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 right? All of that. So this is the mechanism by which the thing is all independently verifiable. It is also, there's a little more technical view of it. I'm not going to explain this because this is terrible and will make your head hurt. But it is also the reason that, again, in the Bitcoin blockchain, maybe not all blockchains, but the Bitcoin blockchain, it is the reason that it is robustly resistant to change in the past, because it is actually mathematically difficult to track back and make changes because of the way things are verified. So we're going to talk about the 4 pieces of that magic that I just described that I think are particularly important, or interesting, or thought-provoking, that might have something to do with library projects, or particularly the 3 library projects I'm going to describe in a few minutes. So the first is the distributed nature of blockchain tech, right? So there's all kinds of different networks, and if you've ever done any kind of network work, you've seen these models before. This is very straightforward. You have centralized networks, you have kind of decentralized networks, or you have kind of hubs and spokes of things, and then you have the actually truly kind of distributed network where each node is independent and traffic can flow in any way. This is the way the internet works, roughly, right? Like TCP/IP, when I say the internet, like the actual underlying structure of the internet is a distributed network. It's very robust to damage. If a particular point gets damaged, traffic routes around it. It's very robust. Centralized networks are very fragile, right? If that center point goes out, suddenly everyone loses everything. Decentralized ones are less fragile, but still, if one of the decentralized nodes goes out, all of the surrounding nodes lose their connectivity. So in Bitcoin blockchain terms, the distributed network is what we're after. Robust, resistant to change. Every node is its own, again, copy of the information. So it's kind of disruptible in the same kind of way that a lot of information sources and networks are these days. If you, instead of talking about it at a network level, if you talk about it in a kind of an information flow level, one of the reasons that blockchain is particularly interesting at Berkman and in kind of the internet world at this point is that a lot of our information flows, the social flows of the things that we create are much more centralized than they were at one point, right? Facebook, Twitter, Instagram, those sorts of things. All of our communications are centralized around those single services, and in, again, a service model that was fully distributed, you avoid that sort of data lock-in and things like that. So there's a lot of work going on that has to do with using blockchain to decentralize services, not just kind of network level, but actually the service level of things. So the other thing that I think is interesting about blockchain is its immutability, the resistance to change. So I'm going to get a tiny bit technical. So the way that each of the individual blocks, you see the kind of you've got the hashes, the previous hashes from the previous blocks. A hash is just a mathematical function, right? It's a way of doing a lot of math. It's a fancy math problem. And the way for the Bitcoin blockchain, not all blockchains, I'm going to say that a lot, but the Bitcoin blockchain, the way that a block gets kind of gets officially made a part of the chain is through what's called mining. And this has to do with very fancy math and lots of very big, heavy computers that burn more coal than almost anything else on the planet at this point, I think. There's a lot of electricity being eaten by these things at this point. But it does a lot of math, and when a particular solution is solved, that indicates that the block can be added to, that particular block can be added to the chain. And every block, in order to change it, you have to redo the entirety of the math, right? You have to redo all of the math that was done in order to solidify it in its place. And if you wanted to change a chain behind the block that you've got, you'd have to do the math on it, and then the math on the one before it, and then the one before it, and the one before it. And eventually, that just becomes kind of more math than a computer can do. Like it is just technically something that would be cryptographically impossible. So the fancy math is what kind of locks the blockchain into where it is and makes it very resistant to change. So verifiability is the third of the things that I think are interesting about the blockchain. And verifiability just has to do with whether or not you know who is putting entries in, and then kind of what happens to their entries. So this uses fairly straightforward cryptographic signing, very similar to kind of secure email or secure messaging apps where there's a public key and a private key. You have a private key, you use your public key to sign your entry into the blockchain, therefore it is verifiable that it is you, mathematically verifiable that it is you. And anyone can browse that and go, oh yeah, that line, second line, that was Jason. Why? Because his key is associated with that particular entry. I can prove that that was him. So the verifiability of every entry, I think, is important, and will come up in one of the things I'm going to suggest might be useful for libraries in a little bit. And then the last thing that I think is really interesting, and this is the part where a lot of people disagree in the blockchain world, is consensus. And I've described this magical database-y thing, and I've told you that anyone can write to it, and that you have to solve some fancy math in order to get in order to add add new entries. And that's all true. But it is entirely possible that you can have conflicting entries, right? It is possible that two people could simultaneously solve a problem, and then you end up with conflict, right? You have two different entries that should be there. In the same way that you can have failure at two disagreeing entries in a database. You have two people fighting over it. That's why databases operate in lock states and everything like that, right? So the blockchain uses a form of consensus in order to determine what choices to make when there is a conflict in the chain. Okay? Those are determined beforehand. When you write the software, you basically put in an algorithm that makes the decision for you. So that it's an automated consensus. This is an algorithmic consensus. Mathematical. It's something that is built into the system. It doesn't involve people most of the time. And we operate kind of in the world, kind of in our social world, we operate via consensus in a lot of different ways. It's just that we don't often think about it algorithmically. Things like the legal system is more or less a consensus-based system. Things like money and inflation are a form of consensus, and the stock market is a form of kind of consensus operations. In the blockchain world, one of the ways of doing consensus work is called proof of work, and this has to do with the way that things are added to the chain, and Bitcoin particularly uses what's called basically the longest branch rule. So whatever, if you have two entries that happen simultaneously, right? So you have two conflicting entries in your chain, the system waits, and it waits for the next thing to be mined. And then when the next thing is mined, whichever chain it gets added to becomes the official chain, and the other one kind of fritters away, becomes an orphan. So you end up with one continuous chain, and that's the way that Bitcoin solves this kind of consensus problem. There are other ways of solving the consensus problem, including ways that I think are kind of only theoretical at this point and aren't instantiated anywhere. But the other one that gets often talked about in the blockchain world is what's called proof of stake. And proof of stake says that whoever has the most stake, whoever has the largest kind of stake in the system, is the one that makes the decision about which chain gets chosen. So if two people attempt to add to the chain at the same time, the system goes, okay, well, Jason has done this more than Nate has. So if I have to make a choice, I'm going to go with Jason. That's the way proof of stake more or less works.
Hey, wait, man.
I know, it's not fair. It's not fair. Consensus algorithms and consensus, the study, kind of the mathematical study of consensus is actually a fairly young part of math. It is really something people are working hard on, and I feel fairly confident that there will be others. The good thing about the consensus part of the blockchain is that you can take one out and put another one in, and it's still blockchain, right? Like the only kind of real key is you need some way to break ties. As long as you have a way, you're fine. But these are the two big ones: proof of work and proof of stake.
Sorry, when you say break the ties, do you
Yeah.
mean like
Simultaneous entries.
Oh.
Yeah. So if there's two simultaneous entries, you have to choose which one to choose,
okay.
right? That's all I need. And the two ways that we currently have to do it are more or less proof of work and proof of stake. I think there are others, but especially in private blockchains, there are other ways you could make it work. You could actually do voting. You could literally vote on which one you wanted if you wanted in a private blockchain. So the four things I think are interesting. Oh, sorry. Let's go back. Distributing, immutable, verifiable, and consensus. Those are the four things that I think are interesting about blockchain. So what can you do with that? Like what's being built? What can you do with both the technology of the blockchain in other areas? And there's a huge amount of work being done. Bitcoin is the big one, and there are all sorts of coins. There's Dogecoin and altcoin and Litecoin, and there's all sorts of coins. Currency is the big kind of thing that people latched on too quickly because using a blockchain for currency turns out to be a really good idea. There's a lot of other options, though. There's a lot of other options on how you can use blockchain in a system. And there's a couple of good reasons to do that. I'm going to talk about that in a second, but I just wanted to give you an idea of the sorts of things people are doing. So Namecoin is a distributed blockchain-driven DNS system. So it's a domain name system for the internet, except driven through blockchain. Bitmessage and Twister are both Twitter clones, effectively, decentralized Twitter. So it's Twitter, except there's no company that owns it, right? It's all out at the edges. Eris and Ethereum, Eris Industries and Ethereum are both companies that are doing work in what's called smart contracts. I want to talk about that in a second, because I think that's a pretty cool area. Stampery is literally an online notary. It's like, we will officially notarize that you gave us this particular file at this particular time, and then we will write that to the blockchain where it will be forever, saved. So it's proof of effectively provenance, right? Like trunk. Deckbound is a collectible card game based on the blockchain, which I thought was fantastic in a weird kind of way. Etheria is a Minecraft clone based on blockchain. So it's Minecraft, except there's no central server. It's all driven out to the clients, and it uses blockchain tech to sync everything up, right? I don't remember Ribbit. You'll have to look that one up. Mycelia is one of my favorites. Does anybody know the artist, the musician Imogene Heap? Imogene Heap. So Imogene is actually working on the system called Mycelia. It doesn't have a website yet, but if you Google Imogene Heap Mycelia, you'll get to her blog entry on it. And basically, what she's trying to do is to build a market for music on the blockchain. So an open, decentralized market where people can buy and share and trade music on the blockchain. Open, I'm going to skip a few of these. Open Bazaar is eBay on the blockchain, basically. Let's see, I don't remember either of those last two. The winner for name, just purely the name, the winner is Token. Anybody want to guess what Token is? It's a fantastic pun. You know? It's financial services for legalized marijuana. It's fine. All right, so the two phrases that get thrown around a lot in the Bitcoin, in the blockchain world, and if you want some Google, some Google tools, these are the two phrases that you want to search for. The first is distributed autonomous organization. Okay, so what in the world does that mean? It sounds like something in a cyberpunk novel that's going to eat us all, right? A distributed autonomous organization is basically that. It is an organization where the entirety of the code of the behavior of the organization is written into the blockchain. Written into a blockchain, which means that it operates entirely decentralized from any owner. Okay? So here is an example of the sort of thing that you can do with a distributed autonomous organization. This is one example among lots of others. So an artist, a friend of mine worked with an artist to build a sculpture that had in it, as a part of its kind of physicalness, a computer, and that computer had in it code that was running on the blockchain that accepted currency on its behalf, so you could send Bitcoin to the sculpture, right? So you could walk over to the sculpture and take your phone and send it some Bitcoin. The sculpture as a thing, as an organization, accepted the Bitcoin. When it got enough money to build a replica of itself, it contacted artists and offered them contracts to do so. And then when an artist accepted a contract to build a copy of itself, it paid the artist, and then the artist built another copy of it, and then it did it again, right? So this is a kind of an autonomous agent that is able to legally interact with the human world through smart contracts and accept payment, and very strange concept. Smart contracts are the other thing I wanted to talk about. So one of the things that people are most excited about with blockchain tech is that one of the things that it decentralizes is the concept of notaries and authority, right? So right now, if you want to, if I wanted to go to Nate and sell him something and write a contract up for it, I would consult an attorney, and the attorney would suggest ways that the contract would work, and then I would sign it, and he would sign it, and we would file it somewhere. A smart contract kind of does away with all of the legal system, because since blockchain can verify that I agreed to something and verify that Nate agreed to something, and that is immutable and unchangeable, and we can always verify it, and the text of the contract itself can be saved in an immutable, unchangeable form. You can do peer-to-peer contracts without kind of outside legal kind of help or arrangement. So smart contracts is something people are really interested in. There are some big players that are playing kind of in this space. Sony just announced a couple of days ago, actually, this is February 22nd, that they are developing an education and testing platform based on blockchain. And IBM is looking at doing kind of blockchain as a service, providing blockchain services to businesses that want to build on top of it. So that it's not just kind of crypto anarchist Bitcoin weirdos, although it is largely crypto anarchist Bitcoin weirdos. But there are big companies that are getting into this game because they think it's got a lot of potential. So speaking of potential, let's talk about possibilities for libraries. So there are kind of three things that I dreamt up that might work that combine the blockchain and library interests. And they go from very simple to much more complicated. So I'll start with a simple one. And the simple one is a word that I already used, and that's provenance. Libraries don't often worry that much about provenance, but it's something that comes up in the museum world all the time, and it certainly lives in the archives world all the time, right? So library and library adjacency, provenance is a big deal, and tracking it can sometimes be really difficult. Tracking provenance becomes a lot easier if the metadata that reflects the chain of ownership or data about the object, during its ownership, is written to an immutable, unchangeable, publicly verifiable source, like blockchain. And of course, it doesn't have to just be physical items that have provenance, right? Digital items can have provenance as well. So if you think about those of you that are in academic libraries, how many of your academic libraries are running a research, my brain just stopped. A repository, thank you. I'm like, repository. How many of you are running a repository? Right? So your repository probably has like data about the things that people put into it, right? But if your repository goes away, then the data goes away, right? Writing the provenance of digital objects into a distributed database that lives in everywhere, probably not a terrible thing to be doing. It certainly is more secure than a server that lives in your closet or somewhere in the cloud, which is just other people's computers. So provenance is something that, again, libraries care about, especially in the instances of things like repositories, but museums and archives care lots about, and being able to do that work in an immutable way is a big deal. The second thing that I think is interesting, maybe, although a lot of people have argued with me about this, Eric, is whether or not it might be interesting to do some form of bibliographic metadata on the blockchain, using a blockchain-like system. So what I have in mind is effectively a decentralized OCLC, right? I mean, OCLC has everything in their one place. But if everywhere could have everything, I think we live in a better world. So, it's a bias. So if we had things like, if we build a chain, if we imagine a chain, and we have a blockchain system, and we're writing book metadata to it, so we have, book 1, and book 2, we have MARC and RDF, whatever else we want to throw in there. And then somewhere along the chain, we want to edit, we want to update a piece of metadata earlier. We can just write that directly there. We can write that to the chain. We can reference the previous one because, well, we have mathematical references for everything all along, up and down. We can continue writing metadata. And, in theory, it could look something like this, where we have metadata saved in the blockchain, in a blockchain here, and then somebody notices that my book is not actually a sound recording. This is actually the OCLC record, so thanks, OCLC. So it's not actually a sound recording, and I want to change that, and I want to dump the subfield H. I want to get rid of the subfield H in the 245, so I just write that to an update on the metadata. and go along adding other stuff. So let's say I have all this data, traveling down the chain. People can update as they will. If I want to pull that data out and put it into a display system, I can read it in a couple of different ways. I can choose the level at which I wanted to display the records about the books. And one way to do that would be to read to the most current chain, right? So I could look at whatever the most current entry is and be like, okay, so that's the state of my bibliographic entry. That 245 should replace the 245 that's in the one previously, so I'll build that right programmatically as I go. And I can do that. We can make as many changes as we want and update them on the fly in our display system as we pull things out. The other choice would be, instead of using the most recent, I could maybe prioritize certain writers, right? Because we have authorship at every level here. I could choose to only display things that the Library of Congress wrote. Or I could choose to prioritize my own local cataloging over the things that the Library of Congress wrote. And I can do that by literally just changing the key that I look at as I fly down this, reading it out. The cool part, I think, right, is that it would be completely distributed and everyone would have a copy of it and it wouldn't be beholden to any particular single actor, and there would be universal agreement, and when someone made a change it would be automatically propagated everywhere, and there would be automated reconciliation of problems, and everyone could always edit it all at the same time instead of being locked out of a connection record. And so I think there's some good things here. I think there's some possibilities. So there's problems too. There's problems. One of the big problems is that bibliographic information is actually really freaking big, and there's a whole lot of it. OCLC has lots and lots and lots and lots and lots and lots and lots of records. But text itself is not that big. So I don't know what this would look like. Would it be bigger than the blockchain, like the Bitcoin blockchain? I'm not sure it would. What do you think? Do you think it would be, if we blockchained all of OCLC, would it be bigger than the number of Bitcoin transactions that have happened? I actually don't know. I don't even know how to get within an order of magnitude being right, but it's possible.
Yeah.
So, but I think there's some potential for something interesting to come out of a system that looks like this. And then the thing that I think is really interesting is the potential to build a system based on blockchain tech that may give us back a right that we don't have now. And that would be for sale rights, right? So the reason that libraries exist is that in the US we have a first sale right to physical items. If we have something physically in our possession, we are legally allowed to resell it, give it away, lend it, burn it, whatever we want to do to it, right? We can do whatever we want. You don't have that right with digital goods. Digital goods are typically licensed to you. But I think one of the reasons, right, that digital things are licensed and not owned is that there is no proof of ownership of them. They are infinitely copyable, right? One of the common complaints from publishers about ebooks is that, well, if we don't give it to you locked with DRM, then everybody will have it and you can just give it away to anybody you want. Well, so what if we had a system that was something like the blockchain, something very, very like the blockchain, where you had a user, and the user wanted a copy of a book, and the system locked that book with his public key, right? So we have cryptographic proof, mathematical proof that user one owns book one, right? And that's provable because we have written it to, again, a database that is unchangeable and time-stamped and cryptographically secured. So if we get to the point where we have this system, user one, book one, we can prove to anyone that asks that user one owns book one. And if user one wants to give book one to user two, he can actually literally take away his own ownership and give ownership to user 2 through a blockchain transaction, in the same way that I can give you Bitcoin. Right? So I can, again, verifiably, cryptographically, make myself unable to access the book and give it to Nate and make him able to access it and prove that he owns it. Right? And we can do that over and over and over. That looks a lot like lending to me. And because we have proof of this, because we have again, cryptographic, mathematically functional proof of every step all the way along, we can prove to a publisher that user 1 can no longer access this book. Even if he happens to keep the bits, he can't unlock it because the blockchain tells him he doesn't own it anymore. Now, the traditional model for this system might be something like publisher and bookseller sell to a library, right? The library checks out the book using this cryptographic system to the user. That's again a fairly common. It would very quickly devolve into the publishers and the booksellers, right, trying to get at them directly, because that's the way they work. Because we've seen this with Amazon, and we know how this game plays. The difference with the system that I'm describing is nobody has any control. It's all decentralized. So once a book is in the system, nobody can stop it. Once it's controlled by this new kind of digital tool, everyone becomes an even player. The library, the bookseller, the publisher, and the users are all on an even playing field. They're all peers in the network. There's no nodes and owners and servers. And, the DRM involved is cryptographic signing keys and public key encryption, which is a well-known and well-backed and easily understood piece of tech. The blockchain records all of the sharing and everything. And I think we get lending with digital objects. Now, the question is whether provable scarcity equals first sale rights. And I don't know if that's true. That's a hypothesis, right? First sale is something that would have to be litigated. I have no idea whether this is legal. It almost certainly is not legal. That hasn't really stopped people from building things before, so I'm okay with that. So I don't know if this is true. I don't know if provable scarcity of digital objects is the same as having a first sale right to them. That is an open legal question. I don't know that. However, I do know that theoretically having a distributed and open market might be a good thing for the publishers at this point, because Amazon's eating their lunch. And having the ability to sell directly to people rather than going through Amazon might make them really happy. I also know that because we can layer the whole thing on top of blockchain, we could actually build into this system microtransactions so that the users could pay for the books directly in the system. All of this could be done through effectively Bitcoin, right? You could use a virtual currency to drive the entire thing. And the transactions involved also wouldn't be locked to booksellers and publishers, right? So if user 1 wanted to give his book to user 2, he could do that. But if user 1 wanted to sell his book to user 2, he could do that too. It would be a completely open market for that sort of thing. One other thing it gives publishers is that because, again, we're running this on a blockchain, all of the transaction data is all open. The publishers would know what the books are that moved around the most, because they could just look and see if their books moved around the most, right? This is all open data. They could see it, which is, again, more than they get now from existing booksellers. They don't get a whole lot of data about that sort of thing from Amazon directly. And then it maintains some pseudonymity for readers. It's not anonymity really, but you could organize this in a way that a reader maintains some pseudonymity. Again, because we're using were using microtransactions via a digital currency, it would be possible to get into this system without having a U.S. credit card and Amazon, the magical key to Amazon, and readers could no longer give their purchasing information away to everyone because you couldn't necessarily prove who was who. So this is very new. It's so new that this is literally the first time I've ever said it out loud in front of a crowd. So I am in the middle of writing a white paper about this, trying to sort out what the pain points are, figure out how one would build something like this. This may be the next thing I try to build. I'm not sure. I'm gonna see kind of where the pain points are. But I think that there's some potential here to do some really interesting things in a market for media, specifically books, but any sort of media could be thrown into this, that's driven in this way. And with that, I'm going to say thanks, and I'm going to ask if you have questions. Yes, ma'am.
Wouldn't the market for the publisher or producer be saturated really quickly and they'd have nothing to sell anymore? Because everybody else is selling it to each other.
Oh, well, I mean, is the market for new books like eliminated by the market for used books?
I think this sounds like it'd be really easy to find a copy when you want it.
It would.
And nobody would lose it at the beach or.
Yeah, it would.
That it would just be too perfect, and
Yeah.
that you would only need so many books to
Did you
saturate.
just say that in a room full of librarians? You only need so many
No,
books?
so many copies,
I know, okay.
sale points or
I know,
whatever
I know.
of
Yeah, it's true.
individual
Totally.
products,
Yep.
Then would it have to dovetail on like BitTorrenting, where you only get parts at a time?
Oh, that's interesting. The atomic units could be different.
Yeah, because if you think about
Yeah.
torrenting, I mean, there's thousands, millions of players, but
Yeah.
you still can't find everything.
No.
I'm
Well,
not saying
you
that.
can't find
that.
in this particular instance, does it have the potential to be very disruptive for publishers? Yes. I find it hard to worry that much about that.
One approach is the Wu-Tang approach, right? If you allow
Yes.
this release one,
That's right. Totally.
secondary
Yeah,
market will decide the price from there.
yeah, that would become the Stephen King model in this. I think. Yeah, that would
What's
become
interesting is that
yeah.
with the public key and the blockchain, you're making that digital copy of that book just the one copy you can't copy.
Yeah. Well, you can't. No one could force you to. You would have to do it.
Yeah.
You would have to do it willingly, right?
Right.
Like you'd have to give it away or sell
Right,
it.
exactly, lose your ownership.
Yeah.
Yeah.
You'd have to voluntarily lose your ownership. Yeah.
Right.
Yes, sir.
How does this work with another movement right now, open access, right?
Yeah.
We're not trying to, we're interested in the provenance of metadata,
Yeah.
and we're interested in the pseudonymity of our users, so we can
Mhm.
track analytics and prove
Yeah.
our boards that we're measuring things just like you're trying to do spatially, but with
Yeah.
data.
Yeah.
How does that work together?
Yeah, so, I mean, you'd still get provenance, right? Because that's the way blockchain works. You could write provenance data into the metadata without any problem, I think. And you would get the transfer information, so you'd see how it bounces from researcher to researcher. You wouldn't know who the researchers were, that's okay. You'd still see how the data moved around. I mean, I think you could dump Sci-Hub into this tomorrow, and it would work out great for everyone. Not that Sci-Hub is open access, I know. But yeah, I mean, I think it would dovetail well with open access. You throw as many copies as you would like into the system and let people share them, and then mine the data out afterwards. I think it would work fine. Yeah.
I just, back to the question earlier, I feel like any of these projects, if they were really to flourish, you'd
Yeah.
have to have a dedicated computer for them.
That's possible. That's possible. I mean, although when you say a dedicated computer, like, I mean, it
A
might
computer in your house.
be a
that's
computer that
specifically-
looks like this.
Right, but still, I mean, I'm thinking about just cost effectiveness. Like,
Sure.
how are you managing these? and then you're constantly updating. What if you get everybody on the planet wanting one particular,
Yeah.
blockchain, and
Yeah.
then you gotta get everybody on the planet's information, even if it's tiny smalls, I
Yeah.
get it, but
Yeah. I mean, scale is a problem for everything, right?
Yeah.
Like, although, by and large, I tend to trust that, in general, scale is fairly manageable in computers via the growth of processors and the increasing cheapness of them, right? So like instantiating this today would be, I mean, not remarkably, but like somewhat expensive on the processing side. You'd have to have a computer probably. But in 2 years, you can probably run exactly the same thing on your phone, and 2 years from that, you'll be able to run it on your e-reader, and then 2 years from that, you'll be able to run it on your cereal box, right? Like, it just gets cheaper to do the same work over time. So I think ultimately, it would be fine, even if like right now, it's not. It's possible. It may not be. There may be, I mean, Bitcoin is intentionally designed so that the difficulty of the math ramps over time. So it actually gets like technically more difficult to do over time. And this has led to an arms race and hardware and all sorts of crazy things. But it doesn't have to be designed like that. It's something like this, I don't think would be. It would be designed for much lower processing power. So.
Well, you're saying that's actually in order to operate this, you have to have the entire blockchain on your computer.
Yes.
So
Yeah.
it seems conceivable it gets so big that your computer can't handle it.
I mean, the phone in my pocket could hold the entirety of the Bitcoin blockchain. Like I'm not too worried about storage. Storage is cheap and ever increasing, and theoretically it could. I mean, one of the interesting things is that the system doesn't actually have to hold all of the content. It just has to hold pointers to the content, right?
Yeah.
So like you could distribute all of the content via BitTorrent if you wanted, and distribute that among everybody, and it, no one place has to have it, but only the data is in the chain, and there's all sorts of things you can play with as far as the storage goes.
But if your system, if you're just storing pointers, aren't
Yeah.
you moving the security question of the provenance just one step outside of the blockchain?
I don't think so. I mean, as long as the hashes match, you're fine, right? Like as long as you can prove.
Okay, so as long as you're talking digital apps.
Yeah. I'm talking digital applications for the yeah. Because I mean, yes, it gets weirder with physical things.
Yeah, well, you said you start with provenance.
Yes,
Digital
totally.
provenance, I got a little bit.
Yeah. No. You're right. I mean, physical objects, yeah, that would